In Module 4, we're talking about graph theory. And the graphs that we're talking about are not the graphs of functions that you've seen for years now. These are very different types of graphs. These are just where we are connecting different points and looking at many different possible connections and things called paths. So there's a lot of things that we're going to be covering in this module. We'll talk about some definitions, just to kind of lay the groundwork for what we're talking about. And then we'll talk about specific algorithms that are useful in determining useful types of graphs. So we'll start by just talking about the definition of a graph. First of all, a vertex is a point or dot which may or may not be connected to other vertices. The connections are called edges, and an edge that connects a vertex to itself is called a loop. When we combine vertices and edges into one whole, we end up with what is called a graph. Here we see an example of a graph, and we're going to talk about the definition of this word degree. Okay, we did talk about the degree of a vertex, and it's just the number of edge connections to the vertex. So here is a picture of an example of a graph. All right, we see these different points. These are all the vertices of the graph, and we see that there are connections between these vertices. These connections are the edges. Okay, so our straight lines are the edges, the points are the vertices. We'd like to find the degree of the large vertex in this graph. So we see here the large vertex is right here, and we'd like to find the degree of this vertex. And the degree is simply the number of edges that connect to it. And we see that there are 4 edges connecting here. So the degree of this vertex is 4. Let's do a few more examples. Determine the degree of the large vertex in each graph. So here we have this large vertex, and we see 1, 2, 3 connections, and so that vertex has degree 3. In this graph here, okay, we see this connection over here, but then we've got this random vertex over here, the large vertex, another vertex over here. And the number of edge connections off of this large vertex, well, we don't see any connections. This vertex doesn't connect to anything. So the degree of that vertex is 0. Here we have what's called a fully connected graph because every vertex is connected to every other vertex. The large vertex here, we count the number of edges connected to it. We've got 1, 2, 3, 4, and 5. So this vertex has degree 5. Let's talk about why we might care about graphs that we depict in this way with vertices and edges. This here is an example of, this is actually kind of the birth of the branch of math called graph theory. So back in the 18th century, there's this city called Königsberg. And there's a river that flows through and branches out, and there's these islands. This island here, and this island, there's these 2 islands, and there's several bridges connecting these different land masses over the bridge. So we've got 7 total bridges that are depicted in the green here. And one thing that people in this town would do just for fun is see if they could start somewhere and walk through and cross all 7 of these bridges exactly once, and then return to where they started. And this was kind of the birth of graph theory. And we're going to draw a picture here just to kind of represent what's happening here. So drawing a graph to represent the land and the bridges of Königsberg, we're going to use the land masses as our vertices. So we've got this landmass up here. I'll just depict that with that vertex. And there's this this island down below it. Okay. And this other island over to the right. and then this landmass down here at the bottom. Okay, so those are kind of my 4 land masses here. And then we've got connections, okay? We've got 2 connections from this upper landmass to the middle. So I'm going to go ahead and do 2 edges. And we've also got a connection from that upper landmass to this other island. So that's that right there. And then we've got 2 connections from this lower landmass up to that one as well. So 1, 2. And we've got a connection from that lower landmass to the other island. So like that. And then finally, we've got a connection from this middle island to the other one. Okay, so there's an example. There's a graph that represents the city of Königsberg, where your vertices represent the land masses and the edges represent the bridges. We want to find the degree of each vertex. Well, this vertex, we've got 1, 2, 3 edges coming off, so that has a vertex, that has degree 3. This one down here also has 1, 2, 3. The one in the middle, representing that middle island there, we've got 1, 2, 3, 4, 5. That has a degree of 5. And then this other island over here has a degree of 3. 3 edges coming off of that. So these degrees represent the number of bridges that connect to a given landmass. Now, this we don't get to see all of the different theorems that come in math due to in graph theory, but just pointing out a key feature in the answer to the question of whether it's even possible to start somewhere and cross every bridge once and then return to where you were. We see here that it's actually not possible because no landmass, okay, no vertex, has an even degree. And in order to start somewhere and then return to where you were, you would have to have that landmass would have to have an even degree, because if you leave and then come back, well, that's a degree 2. And then you could leave again and then come back, and that's a degree 4, etc. And so this was kind of the birth of graph theory, discovering that, well, because there's an odd number of bridges for each one, it's definitely not possible to cross every bridge once and return to where you started.